Hello everyone, welcome back to Olsen Cafe. Can you prove that CE times AE is equals to DE square? Now this identity looks simple, but the proof is hidden in the circle. So let's uncover it step by step. Hopefully you are able to see the beauty of this proof. So over here, we are working with a circle and a bunch of intersecting chords. All right, so from here, there are many circle properties that we can identify, but let us not get distracted by them. So what we want, all right, is only to focus on this equation. All right, so what we have is CE, we have AE, and involve DE. So over here, right, you may already notice that there are two triangles involved, right, which is namely triangle CDE and triangle ADE. Now, are you able to see that these two triangles are actually similar? All right, so let's prove it, yeah? So what I'm going to do is I'm going to separate out the two triangles. So let me draw out the small triangle CDE and the bigger triangle ADE. So I'm going to label the point. All right, so the point that is correspond to point C, all right, will be point D, and then A is correspond to D, and E is correspond to E. Yeah, so I am going to prove that these two triangles are similar. So the first thing that I would like to highlight to all right, before we actually start to prove that these two triangles are similar, right, that is a common mistake that made by students. Yeah, so do take note, all right, of this length AD, this chord AD. Now, in this case, this chord AD, all right, do take note this is not a diameter because in the diagram, it never states that, all right, the line or the chord AD actually passes through a center O. So point O is not given. All right, so therefore over here, we cannot assume, all right, that AD is a diameter. Therefore, which means, all right, angle D, all right, is not 90 degrees, and likewise, because if AD is not a diameter, therefore I cannot assume that angle ACD is equals to 90 degrees. So since, all right, that AD is not a diameter, so which means I can't use angle C and I cannot use angle D. So therefore, this leaves us with, all right, we need to prove the other two angles. All right, to prove for similar triangles, all I need, all right, is to have two equal angles. Now, so therefore, from this diagram here, right, you can easily see, all right, that angle E, all right, these two are actually the same. All right, you notice that this is actually the common angle. So with this, I am able to straight away, all right, state this equal angle, and the reason simply their common angle. Now with this, all right, I need to just prove the another set of the equal angles. Now what will it be? So the only one, all right, that we have is I will need to prove that angle D, all right, is equals to angle A. And let's put this on the diagram and see what do we have. So I have angle D over here and I have angle A over here. Now, so from here, all right, what we also observe, all right, that what do we have in a diagram is I have a tangent, all right, DF, it is actually the tangent to the circle, and I also have a chord, all right, so we do know that, all right, CD is a chord. Now, with the tangent and with the chord, right, we are able to identify the equal angles, all right, which is this angle here, CDF, right, it is actually equals to the angle that is opposite to the chord CD, right, which is this angle here. So what is this theorem here? Right, this is a theorem which is called the tangent chord theorem. So I put this down, all right, so therefore angle CDE is equals to angle DAE, and the reason that I can quote here is tangent chord theorem. Now with this, I already have, right, two equal angles, and hence I know that these two triangles are similar. Now with this, right, things become very simple now. So we all know that if two triangles are similar, right, the ratios, the corresponding ratios are also equal. So let us look at the corresponding ratio. Yeah, so I'm going to take a look at, all right, the side CE and the corresponding sides DE. So I'm going to write down the ratio. So I do have CE over DE. Now I'm going to write down another corresponding side, right, the ratio. Right, so from here, what I can see is, all right, I have a AE involved, so which means I will definitely need to involve this side AE. So with this, I'm going to use the corresponding sides, which is DE and AE. So I'm writing this ratio down. I have DE over AE. Now, since the two triangles are similar, therefore I know that the ratio has to be the same. Now over here, all right, one thing I just want to highlight is, all right, we cannot use, all right, write down CE over DE by looking at the same triangles. All right, we need to write down the ratio, all right, using the corresponding sides. So with this equal ratio, all right, if you make some observation, right, you will notice that I actually got the answer already. All right, so all I need to do is I just do cross multiply. All right, and there I get the answer. So from here, I'm able to prove, all right, that CE times AE is equals to DE squared, and we are done. Hope you find this video useful. Do like and subscribe if this helped you. All right, I will see you in my next video. Bye.